Hey guys, let's go through our final review packet. So for number one, this is a basic solving problem. We just have to get the variable by itself. So we're going to go ahead and add 1 to both sides. Then we're going to multiply by 2. We're going to get the result of 10. If you want to check your work, all you have to do is plug the 10 in for V and make sure that this side comes out to be 4 since this side is already 4. For number 2, again, a typical algebra problem. There are 2 different ways to do this. Most of my students would choose to simplify first. So they're going to go ahead and distribute here. So that's where we got the 15 plus 9p. Then we're going to solve just like the previous problem. We're going to subtract 15 from both sides, and then we're going to divide by 9. That's going to leave us with 6. If you want to check, you go ahead and put the 6 in for p. Make sure that this side comes out to be 69 because this one already is. For number 3, this is a absolute value problem. That's a little bit different. What you're going to do is you want to get the absolute value expression by itself first. So we have to move the 6 first. That's how we get the 1. Now, I apologize. I probably should have left this still in the brackets. If your absolute value expression comes out to be equal to a positive, you continue on. If it comes out to be equal to a negative, you would stop here and write no solution because there's no way that the absolute value of something can be a negative number. But that's not the case, it's positive. So from there, you're going to set it equal to both the positive and negative because the expression inside the brackets could have been both to get a positive result. So you see me doing a over 8 equals 1 and a over 8 equaling negative 1. Then we're going to go ahead and solve and get a by itself. We're going to do both separately. So here I multiply by 8, I get positive 8. Here I multiply by 8, I get negative 8. It just so happened that they are the kind of opposites of each other. That doesn't have to happen. You could have 2 completely different numbers. Again, if you want to check this, all you have to do is plug the answers in. You should be able to plug both answers in, and it will get you negative 5. For number 4, it says tickets for a local amusement park are $12.95 each. You and 5 of your friends go to the park. You decide to pay for all the tickets. How much money will you spend? Well, you and 5 friends is going to be a total of 6. So we just have to take 6, multiply it by the cost, and we get $77.70. For listing the domain and range, we have to list our inputs and our outputs, or our X and Y. So that's exactly what I did. Here's my X's, I wrote them down. Here's my Y's, I wrote them down. They happen to be in order from least to greatest, which is fabulous. A lot of people like to organize it like that. I wasn't being so picky. Also, if there is any repeaters in your domain or in your range, you only have to list it once. You do not have to list it more than once. For number 6, they want to know if it is or is not a function. The first thing we need to do is ask, does X repeat? In A, no repeaters. In C, no repeaters. But in B, we do have a repeater. We have 1, 3, we have 1, 5. In class, we discussed that doesn't make sense. If we plug 1 into a problem for X, we should get the same exact answer for Y, not 2 different answers for the same input. That's because everything we've done is a function. This would not be a function if we get 2 different values for Y. All right, for number 7, they just give you function notation. You need to know that f of 3, this notation here, just means that in the expression, you replace x with 3. So that's what I did. We're going to follow our order of operations. So I did the exponents first, then I multiplied, then I continued with addition and subtraction from left to right. So I end up with 34. For number 8, it's an inequality. With inequalities, you solve like they are equalities, but if you multiply or divide by a negative to both sides, the one doing the work, you flip the sign. So first I solved like the one that we had above. I went ahead and distributed so I can simplify. So I have negative 21 plus 7x when I distribute. Then I moved everything away from my variable. So I added 21 to both sides. I divided by 7. Now, some people do get confused here because it's a negative 77, but it's the 7 that's doing the work. So we do not flip the sign. So it stays as x is less than negative 11. For this problem, I put an open circle on negative 11. If it was or equal to, we would put a closed circle. And since x is less than, all the numbers that are smaller are to the left. So my arrow goes that way. For number 19 and for number 9 and number 10, they are compound inequalities. This is an example of an and one. This is an example of an or one. The and ones tend to be a little bit trickier because they are written together. So just separate it. They both get the middle. So I have negative 15 is less than negative 2k minus 3, and I have negative 2k minus 3 is less than or equal to 5. I do the same work, but I end up with different results. So you see me adding 3, then dividing by negative 2, where I get the positive 6. Also, since the negative 2 was doing the work, I do flip the sign, so that's why you see 6 is greater than k. Over here, same work, plus 3 divided by 2. Again, I flip the sign. I just happen to get a negative 4 here. Now, some people might write it back together as 6 is greater than k, which is greater than or equal to negative 4, but it is proper to write the smaller number on the left-hand side and the larger number on the right-hand side, which I did. I went ahead and put k in the middle. I just have to make sure we talked about how with the inequality signs, you like the guys like eating the larger number. You learned that in elementary school. You want to make sure it's still eating the same item here. So between the 6 and the k, it's eating the 6 still. Between the k and the negative 4, it's eating the k still. So it still says the same thing. For and statements, you're going to graph it. They get graphed on the same number line. For the negative 4, it was or equal to, so we have a closed circle. For the 6, it was just less than, so we have an open circle. And the line is going to go,
clear
sorry.
in Crusader country. All clear in Crusader country. Students and staff, thank you for your cooperation in properly and safely participating in our monthly security drill that we just completed.
Okay. All right. So yeah, I graphed them in the middle. For number 10, I have a compound inequality. It's or. So those are easy. They're separated already. So we just kind of solve them independently. This one I added 1. This one I added 4. I have m is greater than or equal to 0, and m is less than or equal to negative 4. Both of these are closed circles. With or problems, it goes out to the sides. Always, I kind of remember that it looks like rowing oars. All right, for number 11, we have to graph. When we're graphing, we want to make sure it's in slope-intercept form. This one wasn't, so we went ahead and I subtracted the 2x from both sides. So I have y equals negative 2x plus 4. The number in front of the x, the m, is your slope. The number attached by addition or subtraction is your b, your y-intercept. So I have negative 2 and I have 4. For the slope, we go ahead and write that as a fraction. So I just put it over 1 since it was a whole number. For the y-intercept, it's where it crosses the y-axis. So x is always 0 if you want the whole coordinate. So we're going to start with the y-intercept at 4, and we're going to count the rise over the run. In this case, it's negative. So we're going to go down 2 over 1, down 2 over 1. So we just connect the dots and draw our line. Make sure you have arrows at the end. You're always going to the right. The only time we would have a negative number on the bottom and go to the left is if we were working backwards. Sometimes that comes up when we're doing systems because our line needs to be over here instead of over here. Number 12 says to find the slope. Well, here's the formula for the slope. We're going to plug in, I call the first point x and y sub 1, the second point x and y sub 2, and you just see me plugging in the values for the appropriate variables. Now, just here, be careful because it ended up being minus negative 10, so I double negative turn to plus. So I have negative 13 plus 10 equals negative 3, and I have negative 11 minus 6 equals negative 17. Now, since it's a negative divided by a negative, I did change it to positive 3 over 17. You must simplify it. If it was something that could be reduced or divided nicely, you're supposed to do that as well. Okay. Number 13, it says to find the slope. You can find the coordinates of these and do it like you did the previous problem, but that would take longer. For this, you're just going to count it out. That's the fastest. You count from one point to the next, and you're going to make sure that you're going from left to right. So we're going up 2 spaces over 7. So that's why it's still positive. If it were going down, it would be negative. And with these, again, if it can be simplified, you are expected to simplify it. This could not, so you just leave it as 2 over 7. For number 14, we had to write the equation. They give us a point, they give us slope. You're going to use slope-intercept form. When we write an equation, you're using this format. The only thing that you need to find are the m and the b, and those will be changed to numbers that you see at the end. Unfortunately, we have m, we have the slope, but we don't have the y-intercept. So in order to find the y-intercept, I go ahead and I plug in the information that I do have into the formula. That leaves b as a variable, as the only variable, so you'll be able to solve for the y-intercept. So I went ahead and multiplied, and then I added 6 to both sides, so I get b equals 1. And then I went ahead, I put my b in, I already had my m, so I get y equals negative 6x plus 1. For number 15, they want me to write the equation, but they give me less information. So the first thing I'm going to do is go ahead and find the slope. We already did a problem with finding the slope, so here's the formula. We just plug it in. We end up getting a half. Again, we did simplify because it was a negative over a negative. Then for this problem, they give us 2 points. You could pick whichever one you want to plug in like we did for this problem above. I picked this one. It looked easier. You see me plugging it in here. I end up with b equals 3. In fact, if I had been a little bit smarter, I was smarter, but I knew you guys would do it this way. I would have noticed that this is the y-intercept since it's 0, 3. So if you knew that and you could just figure out that b is 3 already, you're more than welcome to do that. But if we did not have that specific point, we would still be able to pick this point too and plug it in and get b equals 3. It doesn't matter which point you plug in for x and y, you just have to make sure that you solve and get what the y-intercept is. All right, for number 16, we have to graph the inequality. Graphing inequalities, again, we start like we would with an equality. So this one, luckily, is in slope-intercept form already. So we have m, we have b. We start with the y-intercept, so it's going to start at negative 2. It's going to go down 2 over 1, down 2 over 1. Now, when I draw my line, I'm going to take a look at what the symbol is. In this case, it's greater than. This one's going to get a dashed or dotted line. If it had been or equal to, then it would have a solid line. Now, for these inequality graphs, you do have to shade. How we figure out where to shade is we test a point. I tend to pick the easiest possible. In this case, it's 0, 0. Now, I can pick any point as long as it's not on the line. If 0, 0 had been on the line, maybe I'd pick 1, 1, maybe I'd pick 1, 2. It doesn't even have to be like the same number, as long as it's a point anywhere on the graph that's not on the line. Then I'm going to plug it into my equation, and I'm going to see how it ends up, and I'm going to see if it's a true or false statement. In this case, it happened to be true. What that means is if it's true, that means this point works. 0, 0 works. That means any of the points on the same side of 0, 0 work. So I shade in this section. If by chance it came out to be a false statement, if it said 0, 0 is untrue, if like it said that 0 is less than negative 2, which is not, negative numbers are smaller than 0, then that would be false, and I would shade the opposite area because that means that all the points that are by this are not right, the other ones are. So it depends. Also, some people know the trick that if you have your y on the left and your expression on the right, if it says greater than, you shade above. If it says less than, you shade below. Completely up to you how you want to handle it. For number 17, we had to graph. For 17 and 18, these are both quadratics. They're just in different forms. This one's in standard form. This one's in vertex form. In standard form, this one's the toughest. You have a formula. The formula is negative b over 2a. That's going to give us the x for the vertex. So a is going to be the number that's in front of x. A is the number that's in front of x squared. B is the number that's in front of x. C is the number that doesn't have an x. I didn't need C, but so I have a is 1, b is 2. I went ahead and plugged it in. And when I solve, I get negative 1. So negative 1 is the x coordinate in our vertex. But I still need to know what y is. In order to figure out what y is, I take my x and I plug it in the original equation. So that's what you see me doing here. I took the original equation and I plugged negative 1 in for x. I go ahead and I solve that and I get y is 2. This is going to be your vertex. That's going to be the first point that you graph. So you plot that. Boop. On a quadratic, the graph is going to look like a U. It's going to look like a parabola. In order to graph these, we need 3 points. One of them should be the vertex, but we need 3 total points. So I already have the vertex. That's the most important. That's like the little bottom part of the U. I just need another point. It doesn't actually matter what point. So I get to pick a number. My favorite number to pick is 0. So I pick 0. That's where I pick that. You can pick any number your heart desires, but 0 is going to be easy. I plug that in for x here. I figure out what y is. I get y is 3. And that's another point that I'm going to graph. So boop, I graph that right here. If I am smart, I realize that with parabolas, they're symmetrical. They're symmetrical through the vertex. So whatever's happening on this side is also happening on this side. So I draw my little dash, dash, dash here through the vertex, and I mirror this point over, and that gives me the whole U. For number 18, this is in vertex form. It's easier. In vertex form, the graph is in vertex form, which means that these two numbers here show us kind of where the vertex is. I have these numbers, but you can see that one of them I changed. Whatever's in the parentheses attached to the x, that one always gets changed to the opposite sign. So that's where I got -2. This stays the same, -1 from. We discussed in class, this changes because technically this is the x, this is the y. In order to get x, I would have to get x by itself, so it would move over. So that's why it always changes. Y stays the same. So this is the vertex. You just plot that. Boop. And then then just like the previous problem, you're going to go ahead and pick whatever number you want as long as it's not a number that has already been used. So in this case, I'm picking 0 because it hasn't already been used. I put it in the equation. I get what y is. In this case, I get -5. I graph that. I remember that parabolas are symmetrical, so I draw my dash, dash, dash line through the vertex, and I'm going to mirror this point over, and then I get my whole U. And this one's facing upside down, and that makes sense because this starts with a negative. If it starts with a negative here, it's going to be upside down. If it's positive in the front, it'll always be upright. All right, for number 19, they want us to write the equation, and they give us the graph. They said, go ahead and write it in vertex form, so we're using this format. That's good. The first thing we need to do is we need to identify the vertex. The vertex is -4, -3, and we're going to plug it into this vertex form. Remember, the vertex came from the numbers that were attached in the parentheses and the one that was connected outside. So I go ahead and I put it in those two places. Don't forget the one that's in the parentheses. You're going to change the sign though. Now, when I have vertex form, there can be a number in the front. In fact, this one had -1 in the front. We don't know what that number is, but similar to the problems where we had to find the y-intercept, where we had b, we're going to plug a point in to this expression and get what a is. They use a as a variable typically in these types of problems. So you're going to pick any point that is on the parabola. I happen to pick this point here, but I could have used this point over here. I could have used this point over here. I could have used this point over here, as long as it's whole numbers and it's on the parabola. I go ahead and I plug these in for x, and then I just solve for a. I calculated, I got 1. 1 squared is 1, so 1 times a is just 1a, or a. I went ahead and I added 3, and I get -1. The only way this could be harder is sometimes maybe it's not 1 here, so maybe you got like a 2 or something, and you have like 2a, and then you have to divide. It is acceptable to get a fraction for these, so don't freak out if you do. And then I just go back to this equation, I take out the a, and I plug in what a is. In this case, it happened to be -1. For number 20, we have to factor. This is a quadratic. These are all quadratics. This is the simpler type. It's in standard form. We do not have a number in the front, so we just ask ourselves what two numbers multiply to give us -50, but add to give us 5. There's a couple of different ways to get 50. We could do 5 and 10. We could do 2 and 25, but 5 and 10 are going to be the combo that works in order to get us the 5. Now, since it's a -50, you know that one of these has to be negative. If the 5 is negative and the 10 is positive, that'll give us a +5. So that's what's attached to the n in your final parentheses. For the next one, this one's a little bit harder because it does have a number in the front. If it does have a number in the front, you are supposed to check and see if it has a GCF. So 3, 11, 16. Are they all divisible by something that I would have to divide out and put in the front? No. So then I'm just going to go straight to the x method. For the x method, we take the number that's in the front, we multiply it to the number that's in the back, 18. Then we are going to still try to find two numbers that multiply to give us 18, but add to give us the middle number. So similar to how we do number 20, we wanted to add, multiply to 18, add to -11. So it ends up being -9 and -2. There are other combos that give us 18, but only -9 and -2 will give us 11, -11 when we add. Now in the x method, what we do with these two numbers is we actually divide them. We divide them by the number that was in front in the very beginning. So we divide them by 3, and I told you guys, go ahead and put the variable with it because it's going to help you see what goes where. Now in the x method, one of them or both of them will reduce. In this case, it was just one of them. 9/3 will reduce to 3/1 plus the signs there. This one doesn't reduce, it kind of stays. And then I just circled these because these are what's going to go in the parentheses. These are the terms. It's going to be p minus 3, and it's going to be 3p minus 2. And for these problems, if you want to check them, all you would have to do is you would multiply them back out, make sure it gives you this. Multiply it back out, make sure it gives you this to make sure you got the correct answers. For number 22 and 23, we have to solve by factoring. When you're solving by factoring, you want to make sure that they are equal to 0. In this case, they already are. Fabulous. And then very similar to what we did above, we're going to go ahead and we're going to factor them. So two numbers that multiply to give me -6, but add to give me -1 are going to be -3 and 2. That's what goes into the parentheses attached to our variable. For these problems, though, we're going to go the next step and solve. So we set them both equal using the zero product property. We go ahead and just solve. So +3 gives me +3, -2 gives me -2. For number 23, we're going to go ahead and we're going to use the X method because this has a number in the front and I could not divide anything out. So I take 4, multiply it to 3, I get 12. So I want two numbers that multiply to give me 12, but add to give me the 8. That's going to be 6 and 2. Now with the X method, we go ahead and we divide both of these by the number that was in front. In this case, it was 4. I said go ahead and throw the variable on just to help you visualize. I said before one of them can reduce or both of them can reduce. In this case, they both reduce. This reduces to 3/2. This reduces to 1/2. Leave it as a fraction because the numbers are going to represent what goes in the parentheses as your terms. So it ends up being 2x plus 3. It ends up being 2x plus 1. If it's positive, it's plus. And then from there, you're going to go ahead and
Excuse the interruption. Teachers,
we're gonna solve. So we're gonna set them equal to 0. So you're gonna subtract 3 and divide by 2. So you get -3/2. You're gonna subtract 1, divide by 2, and you're gonna get -1/2. All right, for number 24, we have to simplify the square root or radical. All we're going to do is we're going to break it into factors, and we want to see if there's any perfect square factors. If there is, we're going to try to solve them. So for 12, there are a couple different factors. There's 12 and 1, but I wouldn't use that one because that just gives me itself. We could have 2 and 6, but that's not a perfect square. 4 and 3, 4 is a perfect square because that's the combo we're going to use. We could take the square root of 4, which is 2. That's why you do not see it in the square root symbol anymore. The 3 stays trapped inside. There's nothing else I could break the 3 down to. For number 25, it's just a subtraction problem with I in it. We're going to treat I like a variable. We know that I stands for imaginary numbers, but when we're adding and subtracting, it's just another variable. Please be careful. This has negative, so you do distribute the negative, so you see that. But we're just going to collect like terms, and your answer is going to be -3 plus 2i. For number 26, it's addition. That's even easier. Again, you just collect like terms. 27 is the one where it gets harder. We are multiplying. So when you multiply, go ahead and distribute this out like foil, whatever makes you think about this easier. 5 times 4 is 20. 5 times 4i is going to be 20i. Negative I times 4 is going to be -4i. Negative I times 4i is going to be -4i squared. Now, with imaginary numbers, we do know that I squared is something special. I stands for the square root of -1. So if we square the square root of -1, the square and the square root undo each other, so the -1 comes out. So whenever you see I squared, you must change it to a -1. So we're going to go ahead and simplify with knowing that. So these go together. So that's where I got the 16i from. We changed the I squared to -1. So the double negative here, -4 times -1 becomes +4. So now I can combine these. So I have 24 plus 16i. For number 26, for number 28, 29, 30, they say to solve by taking square roots. So that is what we're going to do. When we solve by taking square roots, it does not have to be equal to 0. You're just going to get the variable by itself. So here you see me adding 2. Then you see me dividing by 4. You see me taking the square root. Please remember, whenever we take the square root, we must do plus and minus because we have to take into account that we could have originally squared a negative or positive number. So we have to put a plus minus sign in front of the square root whenever we are solving and we take the square root. For 14, just like the one above, all the way up here, I do want to check and make sure there's no perfect squares trapped inside. The only factors for 14 besides itself are 2 and 7. 2 is not a perfect square, 7 is not a perfect square, so it just stays trapped inside like this. For number 9, again, trying to get it by itself, so I subtracted 1. Then I took the square root. Again, don't forget the plus minus sign in front. Now, when I do this, it's -9. I can't take the square root of a negative number because no number times itself gives me a negative. But what I can do is break it apart, and we have a symbol that represents the square root of -1, which is I. Now, since I broke it apart, I can do the square root of 9, which is 3. So my answer is going to be plus or minus 3i. For number 30, you kind of see a combo of everything. I'm going to divide by -3. I'm going to take the square root. Don't forget your plus and minus. This is a negative, so I remove the negative. That becomes I. But 12, we kind of did already above. You know it breaks up into 4 and 3, so I could take the square root of 4, which is 2, but the 3 stays inside, so I showed you one where you have everything going on. For number 31, it's kind of leading into number 32. We're solving by completing the square. So how do we do that whole complete the square process? There's a formula. The formula is b over 2 squared. So b in this case happens to be -16. We take -16, we divide it by 2, and we square it. That's where the 64 comes from. 64 is a magic number that's going to make this problem a perfect square. When I factor it, I'm going to get x minus 8 times x minus 8, which is x minus 8 squared. We use this method for problems where we cannot factor. This I would not be able to solve by taking square roots because it doesn't have m squared and that's it. It has another m here. And I can't solve by factoring because there's not two numbers that multiply to give me 8, but add to give me 10. So we're going to use the completing the square method. To complete the square, what we do is this number is ik. We're going to move it over to the other side. Then we're going to find a nice number using this formula that'll make the problem a perfect square problem. So I'm going to go ahead and do my math here. So b, which is 10 divided by 2 squared, gives me 25. 25 is a nice number. Legally, I have to add it to both sides of the equation, so that way it's math legal. And then I have this expression. This expression can be factored. It's going to be m plus 5 times m plus 5, which is m plus 5 squared. And now I can solve this like a square root problem. I go ahead and I take the square root of both sides. Don't forget to put your plus minus. I subtract 5. I did tell you guys to put that in the front, so that way there's no mistakes. It ends up being -5 plus or minus the square root of 17. I can't break 17 down, so it just stays like that. For number 33, they ask you to use the discriminant to tell what types of answers this will have. The discriminant is a piece of the quadratic formula. It's this piece right here. Since you're using a piece of the quadratic formula, it must be equal to 0, which in this case it is. We've already went over in standard form. A is the number in front of our variable squared. B is the number in front of our variable. C is the one that doesn't have the variable. I'm just plugging it in here so you see me doing it. It ends up being 4 minus 4, which is 0. Now, depending on the type of answer I get, depends on what answers I'll have for the entire problem. This is not the answer to what n is. This is just helping me figure out what type of answers I will have. If it comes out to be 0, you will only have one real solution. If it comes out to be a positive number, you will have 2 real solutions. If it comes out to be a negative number, you will have no real solutions, but you will have 2 imaginary solutions. That's what they're expecting you to know and write down. For number 34, we have to solve by graphing. When we're solving by graphing, what we're going to do is we're going to graph both of these on the same number line. So you see me finding my M and my B. Here I have my M and my B. This one I made like this bluish purple. And you see me doing, it starts at -2, goes down 1 over 1, down 1 over 1. I did do some backwards points because I wanted to fill the entire line out because I didn't know where this line would hit it. It was nice over here, but it could hit over here somewhere. For this one, I started at 2. I went down 5 over 1, and immediately they both intersect here. The intersection is the answer. The answer is at 1, -3. Please, if this is an open-ended problem, make sure you write the answer. By the way, for these, we could also have ones where it's parallel lines. If it's parallel lines, the answer is going to be no solution. Make sure you write no solution. The solution is where the two lines meet. They never meet, so there is no solution. You could also have one where it's infinite solutions. That's where the lines are exactly the same. It's one line on top of the same line, so they touch at every single point, which means all those are answers, so it's infinite solutions, and you would write that. For number 35, we have to solve by elimination. In this one, it's set up nicely for you. It already eliminates. Elimination is when we add them together and try to get something to cancel out. Sometimes we have to force it. So let's just pretend like this didn't work out and we had to get the x's to cancel. What I would do is I would multiply the top equation by 3, the bottom equation by 2 to get it to be 6 and -6, so that way I can cancel out. But in this equation, they were nice. It already canceled out. So that goes, I add everything else together. So I get -1x equals 2. I go ahead and divide, and I have x equals -2. Now you're not done. You still have to figure out what y is. So I go ahead and pick either equation, the top or the bottom. I happen to pick the top. You plug it in, and then you solve, and you get what y is. Oh, and to check these, by the way, you would plug it into both equations. Make sure it works. For number 36, we had to use substitution. Substitution is when you get one of the variables by itself and then plug it in the other equation. Again, this one was already set up for substitution, so it's nice. It could be x by itself or y by itself. It does not matter. It doesn't always have to be y. And you plug it in the other equation and then just start solving, do the calculation. So you see me plugging in this expression for y in the top equation, and then I went ahead and distributed. I simplified, I combined like terms, I moved over, I divided, and I got x equals -4. After I get the first answer, I go back to the original equation, plug it in, and get the second answer. Now, also in these two, you could have no solution or infinite solutions. Those problems, what happens is the variable cancels out, and then you're either left with a true or false statement. If the variable cancels out and it's true, you're going to have infinite solutions. If the variable cancels out and it's false, you're going to have no solution. So please be aware that that does exist for these as well. For number 37 and 38, we're simplifying. It's exponent rules. If I have an exponent on the outside, it goes to each of my factors of my base on the inside. So you get the 3, you get the 3, you get the 3. The 2, you can see that to the third power. The reason why you see x to the 6th is because when you have an exponent raised to another exponent, you multiply. So that's how I got 6 and I got -6. You must have positive exponents. So if I have a negative exponent, this whole thing is over 1. It must flip. So this is going to go to the bottom. I did calculate 2 to the third power is 8, and I only flipped the y because that's the only one that has a negative. So it goes down here. For number 38, this one was division. So I went ahead and divided 3 divided by 1 because there's no number here. It's just 3. U to the first divided by u to the -2nd. You subtract the exponents when you divide. So you see me doing 1 minus -2. Double negative turns to a positive. So that's how I got 3 down here. And you could think of this two ways. You could think of this as either 2 minus 2, which is 0. Anything to the 0th power is just 1. So you could kind of eliminate it. Or anything divided by itself is 1. So you can eliminate it that way. Either way, you're going to get 3u to the third power. For number 39, this is just a straight up addition problem. So you just combine like terms. Please remember that you're adding, you are not multiplying. So do not touch those exponents. You're just putting like terms together. This guy had no friends. I just dropped him. This guy had no friends. I just dropped him. M squared, I have this guy and this guy, so it became -2m squared. For the ones that did not have a variable, this guy and this guy just ended up being 7. For number 40, this is subtraction, so please make sure that you go ahead and distribute that negative. You see me doing that here. And then again, we're just combining friends. So I happen to have 8a to the 4th and 6a to the 4th, so that's where I got the 14th a to the 4th. I have the 7 and the 5 here with the a squared, so that ends up, sorry, -5. So that ends up becoming 2a squared. And then I have the 7 and the -8, so that becomes -1. Now, in these, you are multiplying, so go ahead and distribute. 3b times 5b is going to be 15b squared. 3b times 8 is going to be 24b. For number 24, you could go ahead and distribute or FOIL, whatever works for you. Now, after I do my multiplication, so you see me doing the multiplication here, then I am adding. When you are adding, do not touch those exponents. So that's why I have 29r. Do not make it r squared. I had a lot of people do that. This is my final answer. For number 43, we're using Pascal's triangle. For Pascal's triangle, first we have to draw the triangle. So you start with the 1 on the top. You will always have a 1 on the left and the right. After that, you're going to add the previous row, and it goes in the middle. Add the previous numbers, and it goes in the middle. So 1 plus 1 is 2. It goes in the middle. You always have a 1 on the left, a 1 on the right. 1 plus 2 is 3. 2 plus 1 is 3. 1 on the left, 1 on the right. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. You see how I add it? It goes in the middle below. And then you always have a 1 on the left and a 1 on the right. I can continue this process, but I only need to go up to this row because I want the row that has a 4 after the 1 because that's what our exponent is. Then when we're using Pascal's triangle, if it's to the 4th power, we're going to write 5 blanks. You're going to fill in those 5 blanks with the numbers from Pascal's triangle. So 1, 4, 6, 4, 1. And then what you're going to do is you're going to take each of these terms, so 2y, you're going to raise it to the power and then keep going one less. So I have 2y to the 4th, 2y to the 3rd, 2y to the 2nd, 2y to the 1st, 2y to the 0th we don't write. And then I go the other way. I have 1 to the 4th here, 1 to the 3rd, 1 to the 2nd, 1 to the 1st, 1 to the 0th, but I don't write it. So you can see it goes kind of like both ways. Then after here, I'm just going to simplify what I have. The first and the last are pretty easy because they're always just times 1. So 4y to the fourth, 2y to the fourth. You do 2 to the fourth power, y to the fourth power. That gives you 16y to the fourth. And since it's just 1, 1 to the fourth power is just 1 times 1. These are where it gets tricky. I do these in 2 steps. First, I do the exponents, then I multiply. So I'm going to do 2y to the third. So 2 to the third is 8. Y to the third is y to the third. 1 to the first is just 1 to the first. And then you see me doing the multiplication. So 4 times 8 times 1 gives me 32, and I bring down the variable. Over here, you see me doing the exponents first. So 2y to the second gives me 4y squared. 1 to the second gives me 1. And then I just multiply the numbers. 6, 4 times 1 gives me 24, and I bring down the variables. Here again, 2y to the first is just 2y. 1 to the third power is 1, and I just multiply the numbers. 4 times 2 times 1 is 8y. And I already did this one. For number 44, you classify this by the degree and the number of terms. Your degree is just your highest exponent. So this is to the fourth power. Here you have the listing of the names by degree. So fourth power is quartic, but here you have all the other ones too. Then you have to classify it by how many terms. This happens to have 4 terms. 4 or more will just be polynomial, but if you had 3 terms, 2 terms, 1 terms, I listed all the names here so you can remember them. For 45 and 46, we're talking about end behavior. One has it as the symbols, one has it as like a graphic. For these, we have to look at the degree. This one happens to be odd because your degree is 3. This one happens to be even because your degree is 2. Your degree is your highest exponent. Then we also have to look at the number that's in the front. In this case, it's 1, which is positive. In this case, it's -1, which is negative. So this one happens to be odd positive. This one happens to be even negative. Okay, here's my little graphic, my little chart here that might help you out. If it's odd, the ends are going in 2 different directions. If it's even, the ends are going in the same direction. So this one's a little tougher. Since it's odd and positive, I told you to think of slope. It kind of starts down on the left-hand side and works its way up. Now, how these symbols work is over here on the right-hand side, this is just telling you left, right. X negative infinity, X positive infinity just means the X axis on a coordinate plane. So this means left, right, left, right, left, right. Over here is really what you're paying attention to. This is what the expression is. So you want one that says it's going down on the left-hand side and up on the right-hand side. That's choice C. Now for number 46, we said this is even and negative. That's easy. Evens go in the same direction, so it's either this one and this one. And since it's negative, they're both going down, so that's choice B. For 47, we have to divide using long division. That's your big old long division bar there. And so we're going to go ahead and just think process, hey, we take a look at the first 2 terms, x and x to the third. What would I need to multiply x by to make it x to the third? Well, I would have to multiply it by x squared. So we do that. We go ahead and multiply this expression by x squared, but we have to do the entire thing. So x squared times x gives me x to the third. X squared times 7 gives me 7x squared. When you're doing long division, you always subtract the number that's underneath. So we're subtracting the expression. So that's why you see me changing the symbol. So that's why I have minus minus here. I distribute this negative. So this cancels. I end up with 5x squared. Drop the next number. Ask the same question. What do I need to do to multiply x by to get it to be 5x squared? Well, we will multiply it by 5x. And then you go ahead and you actually do that. So 5x times x gives me 5x squared. 5x times 7 gives me 35x. And then I'm going to go ahead and subtract this. So that's why, again, you see me changing the symbols. So here we go. I end up with 2x. This drops down. I apologize. When I scanned this got cut off apparently. But then I'm going to go ahead and see what do I need to multiply x by to get 2x, and it's 2. So 2 times x gives me 2x. I'm sorry you can't see it. 2 times 7 gives me 14. And in this case, it happened to cancel everything out when I distribute that negative. So I did not have a remainder. So that's nice. For number 48, this is synthetic division. You guys tend to like this better. You draw this big old box. The numbers inside the box are from the coefficients of what I'm dividing into. By the way, if you're missing any terms, you do put a 0. Same thing with here. We just happen to not be, so I didn't stress. What I mean by missing any terms, if it went from r to the third to r to the first without an r to the second, you put in a 0. You have to go to cubed, second, first, 0th. You have to make sure you have every single term. Now, the number on the outside tends to be the opposite of what's connected. period, because mathematically what you're doing is you're actually like setting an equal to 0 and moving it over. But if you remember to just kind of change it to the opposite, that's fine. Now, to do synthetic division, you just take the first number, you drop it down, and then you go ahead and you multiply. 1 times 9 is 9. Inside the box, you're always going to add. So 1 plus 9 is 10. On the outside, we multiply. 10 times 9 is going to give us 90. On the inside, we add, so we get 5. On the outside, we multiply, we get 45. Again, we add. This ended in a 0 again, so we don't have a remainder. That's nice. You do need to write your final answer like this. So how we write our final answer is we take one less exponent than we started with. So if this was r to the third, we're going to start our answer with r to the second. And these are our coefficients. So you can have 1r to the second plus 10r plus 5. If you had negatives, it would just be minus. Okay. For number 49, they want to know if it's a factor. If it's a factor, that means it divides in nicely, no partial pieces. So all you're asking yourself is, hey, does this have a remainder? So again, I set up my synthetic division. So you see me doing my coefficients here. You see me changing the sign here to a negative, and I dropped, multiplied, added, multiplied, added, multiplied, added, and this one does have a remainder. So no, this does not go in nicely. It is not a factor. For number 50, they ask us to factor, but this is a large expression. They do give us a 0. So if they give us a 0, what we're going to do is, since it's a large expression, we're going to break it down using division and make it smaller so it's something that's easy for us to factor. So in this case, we're going to use synthetic division again, like we did these other problems. The reason why I do not change the sign here when it's a 0 is because it's already solved for. So that's why you keep it as -2. And then I'm going to do my synthetic division. So you see me drop it down, multiply, add, multiply, add, multiply, add. And then I wrote the expression. They were asking me to factor this, so I did write it as a factor. So you do see me changing the sign here. And then I get x squared minus 7x plus 12. And we've already did this kind of factoring. What two numbers multiply to give me 12, but add to give me -7, and they're going to be -4 and -3. So that's my answer here. Okay, for number 51 and 52, we have to graph these rational expressions. Now, with these problems, you're going to have hyperbola. I did graph them down here so you can kind of see it. I apologize when I move the screen a little bit. It's kind of doing that. Let me see if I can make it. No, it won't let me make it smaller. I apologize. All right. So for these problems, what you're going to do is, first of all, we only went over the simple types, and you're only expected to know the simple. Oops, sorry. You're only expected to know the simple types.
One more last announcement.
You're only expected to know these types. Now, when we're graphing these, they're going to be a hyperbola. They look like this. And what we need to do is first find the vertical and horizontal asymptotes. Now, no matter which style I give you of the two that we discussed, to find the vertical, all you're going to do is just take the denominator and set it equal to 0. So this, you see me setting equal to 0. I move it over, so I get +1. And this, there was nothing else attached, so it's just 0. That's not always the case. You might have to do a little bit of calculations. That just happened to be how it was in this problem. Now, for the horizontal asymptotes, that's a little bit different. For this style where I just have x on the bottom, it's what's attached. So in this case, it's a +1, so y equals 1. For these where I have x on the top and on the bottom, what you're going to do is you're going to put y equals, you're going to put a fraction bar, and then whatever you have in front of x on the top goes on the top of the fraction. Whatever you have in front of x on the bottom goes on the bottom of the fraction, and then you just simplify. So in this case, I probably did, it probably got cut off. It should equal -2. Okay, and then you're going to draw those. So you're going to have your dashed lines for your vertical and horizontal asymptotes. But I still need to know where my graph is. I don't know if it's going to be like this and this, or over here and over here. So in order to figure out which areas the hyperbola are going to go in, I have to pick a point. I can pick any number I want to plug into the problem. The only numbers that I should not pick is what I got for my vertical asymptotes here. So I should not pick 1 in this problem, and I should not pick 0 in this problem. And this problem, I happened to pick 2 because I knew 2 was going to make it nice and easy. So that way I didn't end up with any fractions. But even if you end up with fractions, it is what it is and you'll just deal. So I plugged in 2 into the equation, this equation right here, and I come out with 3. So I have a point at 2, 3. So I go ahead and I plot that point. And since I plot that point, that means that 1/2 of my hyperbola is over here and the other half is over here because we talked about the graphs that we were doing had symmetry diagonally. Now for this one, I ended up picking 1. So I plugged that in. So I plugged 1 in for x here and here. So you see me doing those calculations. I ended up getting 1, -8. So I plotted that point. You can't see very well, but it's down here. And then I knew that my graph is going to be in this section. And then that means that it's also going to be in this section. So it ended up being graph C and graph B. Okay, for number 53, we had to simplify. Again, we're doing our factoring that we've already done in the previous problems. I want what 2 numbers multiply to give me 15, but add to give me 8. That ends up being 3 and 5. With these, you're going to eliminate any common factors that you have both top and bottom, but they must be factors. It must be connected by multiplication. So this entire expression matches and it's connected by multiplication, so we could cancel both of those. So I'm left with p plus 3 over 1 or just p plus 3. In number 24, we are multiplying. Multiplying is pretty easy because with fractions, it's just across the top, across the bottom. Again, we are expected to simplify. So you see me factoring when factoring is possible. For this, I thought of what 2 numbers multiply to give me -35, but add to give me 2, which ends up being -5 and +7. I did have a common factor. These I canceled out. I wasn't able to cancel out anything else. So you see me having m minus 5 over 2m squared. Do not cancel this m with this m. This m on the top is connected by subtraction. It is a term. You cannot cancel it out as a factor unless you have the entire expression m minus 5, which you do not have. All right, for number 5, it's division, but division is just multiplication in disguise. It's keep, change, flip. We're going to keep the first, change the sign to multiplication, flip the second. So you see me doing that. Now, in the second one, you also see me doing the factoring that we know how to do for this bottom that I flipped to the top. What 2 numbers multiply to give me 24, but add to give me -10, end up being -6 and -4. So you see that. On the top here, which ended up in the bottom, I was also able to factor. This is not a quadratic, but it does have a GCF. We are still supposed to check and see if there's a common factor, a number or a variable that can be divided out of all your terms. In this case, 8 and 32 are both multiples of 5. So I'm sorry, are both multiples of 8. So 8's a factor that you can pull out. So you see me doing that. I divided 8 out, which leaves r minus 4. And then this ended up being a common factor with one of the others. So I was able to cancel it out and I was left with 5 over 8. Don't forget, even if it's numbers, you can reduce it. Like if it was 4 over 8, I am supposed to reduce that as well too. For number 56 and number 57, we are doing addition and subtraction. That's actually tougher with fractions. We have to have a common denominator. Number 56, you have a common denominator, so that's lovely. You keep the denominator, you combine the numerators. In this case, it's addition, so I just combine like terms. Please be careful. If it was subtraction, we would have to distribute the negative to all the terms behind, but it wasn't, so I just ended up doing 3x plus x, and I get 4x. If there was something that needed to be simplified, like this problem up here where I had to factor and reduce it, like let's say it was 4x minus 4y and I could pull out the 4, I am still expected to do that. So just be aware. For number 57, the denominators did not match, but I can make them match. If you see something in the denominator that can be factored, go ahead and do it. So you see me factoring this to be x minus 7 and x plus 2. Now, they both have an x minus 7, but this one did not have an x plus 2. But it's very easy for me to give it the x plus 2. Just to make it math legal, though, what I multiply on the bottom, I also have to multiply on the top to make it match. So you see them matching now, and I simplified the top by distributing. Then from there, they now have the same bottom. So I keep the bottom, I keep the denominator, and I combine the numerators. Again, this was plus, so it was nice. Be aware, though, that if it's subtraction, you do have to distribute the negative. For this final answer, I didn't like that it was 2x plus 14 because 2 and 14 are both multiples of 2. I could pull that factor out. So I went ahead and did that. However, I was kind of sad because it does not cancel out. This is x plus 7. This is x minus 7. I cannot cancel those. There's nothing I can do. Do not cancel this 2 with this 2. This is connected by addition. So I just left it like this. So technically, if you left it like this, since there was nothing else that could be factored, you could, but I left it like this to show that I knew that, hey, this was factorable, but I can't cancel it. For number 58, well, for this whole section here, we have matrices. For number 58 and 59, we have to add and subtract. With matrices, when we're adding and subtracting, they must match. They must have the same dimensions. Number 58 does not have the same dimensions, so it's undefined. For 59, they do have the same dimensions, so all we do is we add the numbers that are in the same spot. If it had been subtraction, you are subtracting the numbers that are in the same spot. Just be careful for double negatives because those could show up too. For number 60, it's multiplication by a scalar. That just means that you take this number on the outside, multiply it to all the numbers that are on the inside. Please make sure your answers are written in the right format. It must also match the matrix that you started with. For number 61 and 62, these are the ones that are harder. These are the ones where you have to do a matrix times a matrix, and it's not like any other type of math except for matrix math. What you're going to do is you're going to write the dimensions. The dimensions go rows, columns. So this has 2 rows, 2 columns. Rows are horizontal, columns are vertical. This has 2 rows, 2 columns. If the numbers on the inside, so this 2 with this 2 match, you can multiply them. The numbers on the outside will give you the dimensions of your answer. So our answer is going to be a 2 by 2. Now, first thing I do is I literally draw the box with all the blanks. So I know it's going to have 2 rows, 2 columns. So I just drew a box with the 4 blanks. Then what I did was I wrote the positions so I know what to calculate. This is a row 1, column 1. So you see me circling row 1 here, column 1 here. This will always be circled rows. This will always be circled columns. Then what we're going to do is we're going to match up the numbers and multiply. So I'm going to do 5 times negative 3. That's where I get the negative 15. I'm going to do 3 times 1. That's where I get the 3. Any calculations that I get, then I add them together. So that's how I got negative 12. I'm going to do this for every position. So then I have row 1, column 2. So I apologize, I can't draw all of these because then it's just going to look like a whole mess. So it's row 1, so still this one that's highlighted, but this time we're doing column 2, this one over here. So we're going to do 5 times 5, get 25. We're going to do 3 times negative 3, get negative 9. Add them together, I got 16. Then we're going to do row 2, column 1. So this row here on the bottom, this first column. So 3 times negative 3 will give us negative 9. 3 times 1 will give us 3. We add those together, we get negative 6. And then row 2, column 2 are the ones that are not circled. So row 2, column 2. So 3 times 5 is going to give us 15. 3 times negative 3 will give us negative 9. And that's where we get 6. This is our final answer. Okay, for number 62, this is 2 rows, 1 column. This is 1 row, 2 columns, but we can still multiply this because the inside numbers match. The outside numbers will give us the dimensions of our answer. So again, I went ahead and I drew myself a 2 rows by 2 columns box, and I had like just little blank lines. I had 4 blanks. Then I went ahead and I wrote the position. So this is row 1, column 1. So I circled row 1, I circled column 1. In this case, it's easier because I don't have multiples that I have to do the calculations for. It just gives me the answer instantly. So 1 times negative 3 is negative 3. Row 1, column 2, so 1 times 5 gives me 5. Row 2, column 1, so negative 6 times negative 3 gives me 18. And then row 2, column 2, so negative 6 times 5 gives me negative 30. And this is my final answer here. Right. Now, this is the most recent thing we did. For number 63, they want me to draw the rotation and draw where the angle ends up. So this one is just a tiny bit harder though, because this says negative 265. Just to let you know, if it were positive, we go this way. It would be 0, 90, 180, 270, 360. But this is negative. Since it's negative, we're rotating backwards. So it goes to 0, negative 90, negative 180, negative 270, negative 360. I didn't even write the negative 360 because we don't go beyond negative 270. So it stops right here, and I draw my little line. For number 64, they want us to find coterminal angles. That refers to this. We know that a full circle is 360. So I can have a line that's here, that's 0, let's say, and I can have another line where it went a full circle and it's the same picture and it's 360 degrees. It ends up being in the same spot. You have to think on that, and that's what you're doing for these problems. What you're going to do is you're going to rotate this given angle a full circle. So a full circle forwards and a full circle backwards. So that's why we're going to add 360 and we're going to subtract 360. So we're going to get 575 and we're going to get negative 145. For number 65, this is just your trig functions. You had all the formulas. We had sine, cosine, tangent. We had cosecant, secant, and cotangent. So you have those formulas. For this triangle, they only gave me 3 of the sides. So just by instinct, I went ahead and found that third side because I'm just used to doing that. So you see me using the Pythagorean theorem. This happened to be the hypotenuse, so I put it, the missing side happened to be the hypotenuse, so I left that as C. And I found that the missing side is 15. But you see, I crossed that out because I was like, oh boy, I didn't even really look at the problem because the formula for cotangent is adjacent over opposite. So from this angle, the opposite side is 12, the adjacent side is 9. I didn't even need the hypotenuse, but I don't know what you have on your final, so you might need that missing side. So it's good that I did this anyway. So I ended up getting 9 over 12. If it can be reduced, you are still expected to reduce it. So its final answer is 3 over 4. And that's the last problem. So if you have any questions, please contact me.